An introduction to Docker. What does that have to do within a Liferay training? Well, easy. At least we'll need the basic vocabulary. You guys might know Docker. Some of you said we are using Docker and we want to know how to do it correctly when we did the introduction round. Some might not use Docker at all and just wonder what this all is about. And we're at least going through some basic vocabulary in here. What is Docker? What is a Docker image? What is a container? And what is all of this world about? So basically, Docker is a way to run all of your software in something that feels like a virtual machine, but is a lot more lightweight than an actual virtual machine. We'll start with something running an application with all of its dependencies, as it says here, in a standardized unit for software development. What does that mean? This standard unit in Docker is known as Docker image, and you can think of that as a file. Basically, you'll create a Docker image, which is a file that then you can run as a container at runtime. The Docker image will basically run as a process with just the bare minimum, not even a full OS running within it. So it's just a bare minimum virtual machine. That's simplified, yes, I know, but it is what you barely need or what you absolutely need to run the software in there. And to build a Docker image, as it says here, you'll need a Docker file. What is that? Well, it's the one instruction, the blueprint that tells us what goes into this Docker file. And in true 2008 notion, it declares a lot of dependencies, and those dependencies will be automatically resolved and go into the Docker file as well. When a Docker image is run, it becomes a container. In other words, you can distribute Docker images. Those are files that you can download from somewhere, but you cannot distribute Docker containers in a way because they are running processes. A container, as I say here, is an application packaging format. I kind of covered that. It allows you to run applications that share an OS kernel, so they're rather a process than a full OS virtual machine. And each parts of the applications are isolated from each other. We've had that in the last chapter. We said the minimal Liferay installation has the Liferay image, an Elasticsearch image, and a database image. So those are three processes that run in complete isolation from each other. And typically, I gotta say, typically in a production system, you want to run them on different servers because they all will eat up your CPU, your memory, your I/O. And that is basically what you don't want to share in order to get the maximum performance out of your systems. So in production systems, you will run a database server, a Liferay server, and an Elasticsearch server somewhere. Now Docker allows us to abstract away from that and run all of that within just one system, within your one notebook. I don't see anybody here who brought 3 notebooks, so we would be very hard-pressed to actually run the 3 processes on different servers. So good thing that we have this abstraction layer. Now, it says here 3 ways to store data in Docker: bind mounts, volumes, temp fs mounts. That is a hint that the processes run, and once the process is done, nothing changes in the image. In other words, everything is transient. Nothing gets stored on disk if you just run a Docker container or a Docker image. If you run the Docker image as a Docker container and you shut it down, nothing in the world changed. A lot of things have been processed and computed, but nothing was persisted to disk because there is no persistent disk unless you use a bind mount, a volume, or temporary file system storage, which is worth noting because we're not dealing with a full virtual machine. If you set up a virtual machine, you say, well, I'd like to have it this much of disk space and this much of CPU power and so on. With Docker, you basically just use a single process, and if it stops, it stops. And we're seeing which volumes or which parts of the file system Liferay needs to be persistent once we set it all up. Because after all, when we set up Liferay, when we shut it down and restart it, we want to find the same system that we left. We don't want to start from scratch again. naturally. It says here, volumes are recommended as a preferred way to persist data generated by containers. And in fact, we are going to use volumes. If you have a different setup, be my guest, but we are now covering volumes right here. Little bit of Docker PR, so to say. I'm really happy that we use Docker. It's the simplicity. Docker images are really simple, and I can attest to that. When I went through this course for the first time, I immediately got everything that was in there. So it is really easy. Portable. We will have all of these exercises on whatever operating system you run. I see a little bit of fruit in here. I see a little bit of non-fruit, and I'm personally running Linux. So I guess we probably have all of the available operating systems in the room, and we definitely have them out in the world. Reduced overhead, so we don't need the additional operating system. This is a lot more lightweight than a full virtual machine with its kernel, with all of its setup and boot time and so on. And the shared data, we can easily share volumes there to just access the same data, store data in the same positions. Now, your next task will be to set up Docker, unless you have it set up already. We are using, well, we're recording this in October 2018. We're using the latest version as of now. I got to look up the version number to let you know, just in case something changes in one of the next major releases. But you will find that in the training material. You guys know whatever you find today on docker.com is the current version. And everybody out there, if there are adoptions needed because of new images, we will let you know in the written material. Now, speaking of written material, the written material has the installation instructions. If you don't have Docker up and running yet, what you'll need to do on Windows is you'll need to download the latest version. You may or may not need to create an account for that. Then you can test the Docker installation, which you'll do on the command line with docker run hello world, and that will basically run a very simple image, printing out a few things, and that's I would say, the simplest possible container. And then we're going to install the course exercise files, which are just a single zip file that you can unzip, and it contains everything pre-configured for you. Check and run Docker, update Docker settings, that's it. Setup on Docker on Linux is also quite easy. I got to say, this was one of the most easy installations that I did on the Linux machine here. And Docker on Mac OS, I've heard good things about that as well. I'm personally not using it, but it just worked. Now, the written material on the exercises on University, as well as the book, contain the detailed instructions, because you probably don't want to do the exercises like this, figure out everything, like download, run, test, update, that's it. Should be done in a minute, but if you look at the detailed instructions in the book, it will be a little bit more complicated. If you look at your summary box, then we have something that is a standardized unit in Docker. I was thinking of an image, rather. Yeah. There is some file that lets you define everything that needs to go into the application or into the image, which is the Docker file. When an image is run, it becomes a container. The recommended way to store data to make it persistent is a volume. There we are. Perfect.